Let's take a look at a trig function and where it increases and decreases. For example 2, we have f of x equals sine of 2x. We want to figure out where it's increasing and decreasing on the interval 0 to pi. So we have a limited interval here. We're not going to be dealing with negative infinity, infinity, only from 0 to pi. And we know because trig functions go up and down, we pretty much want to just look at a particular section of that graph from 0 to pi. Remember that a function can only change directions at critical values. So first step 1, we're going to find critical values. Taking the derivative first of sine of 2x. Derivative of sine is cosine of 2x multiplied by the derivative of the inside times 2. So our derivative is 2 cosine of 2x. Now, critical values occur where it doesn't exist and where it equals 0. This exists everywhere on its domain, so we're only concerned where it equals 0, so we're going to set it equal to 0. Now, when we divide both sides by 2, we're still going to just get 0 equals cosine of 2x. So how do we solve it from there? Well, to get x by itself, we have to get rid of this cosine, so we're going to take the arc cosine of both sides. And now we have arc cosine of 0 equals 2x. Now, be careful here. You might think, well, we're only going to include pi over 2 because that's the only one that's between 0 and pi. But remember, this is arc cosine is equal to 2x. So if we get x by itself, we'll end up dividing by 2, and we might need to include this because, look, if you divide this by 2, you get 3 pi over 4, which is in the interval. So follow these steps to ensure that you get all your critical values. You want to get x by itself first. So we're going to divide both sides by 2. We get arc cosine of 0 over 2 equals x. And now comes the part where we were given the interval. We were given the interval of 0 to pi, right? And so we know that x is between 0 and pi, okay, including those values because of the bars. Well, if arc cosine of 0 over 2 equals x, we can replace the x with arc cosine of 0 over 2, which is what we're going to do. So we know arc cosine of 0 over 2 is between 0 and pi, and if we do some inequality multiplication and multiply all of this by 2, we will get a new interval. Okay, so it'll be 2 times 0 on the left, which is just 0. In the middle, the 2's will cancel, will be arc cosine of 0. On the right, 2 times pi is 2 pi. So this tells us that our arc cosine answer must be between 0 and 2 pi, and we will be allowed to choose those two values on the unit circle, 2 angles where cosine equals 0. Again, it's on the y-axis. It's going to be at pi over 2 and 3 pi over 2. X will be equal to 0, so cosine will be equal to 0. So this tells us to include all the values within the unit circle. You might have gotten a different interval. You might have got, say, from 0 to pi. In that case, you would only include pi over 2. You could have gotten 4 pi. In that case, you would have had to include 5 pi over 2 and 7 pi over 2. So we want to make sure that our arc cosine of 0 equals these two values, and you're going to see how it works out. Here's why it works out. When you plug those values back in for arc cosine of 0, so basically we're just doing some substitution, you're going to end up dividing those by 2 in order to get your x value. Well, if you divide pi over 2 divided by 2, you get pi over 4. And if you divide 3 pi over 2 divided by 2, you get 3 pi over 4. And guess what? Those are actually, both of those are between 0 and pi, our original interval. And that's what we wanted. Okay, so we do end up with two x values that are in between the interval that we need. Pi over 4 and 3 pi over 4 are between 0 and pi. So that gives us 3 intervals. Remember, if you're given 2 critical values, you get 3 intervals. And remember, we start at 0. So our first interval is from 0 to pi over 4. Next is in between our 2 critical values, pi over 4 and 3 pi over 4. And finally, 3 pi over 4 to pi. Pi was our right endpoint value. Okay. So we're going to write our chart out just like we did before. For increasing, decreasing, on our first column, we're going to have our 3 intervals. Next, we're going to plug in test values. Now, this helps to have a concept of the unit circle. If you look at the unit circle between 0 and pi over 4, there's actually just one angle, and that's pi over 6. So that's what we're going to plug in for our first test value. Next, any angle between pi over 4 and 3 pi over 4 will work. I would recommend pi over 2. If you want to think about degrees, that's 90, which is in between 45 and 135. You certainly could plug in, say, pi over 3 if you wanted to, but this is easier. And then finally, 3 pi over 4 to pi. There is one angle in the unit circle that's between those two, and that's 5 pi over 6. So those are our three test values. Let's go ahead and plug them in. Again, you're plugging those into the derivative because the derivative tells you where it increases and decreases. So I'm going to plug in pi over 6 into the derivative, which is 2 cosine of 2x. I'm going to plug in pi over 2. I'm going to plug in 5 pi over 6. All right, now how do we get these? Well, this would give us what? Pi over 3, so you'd have to figure out cosine of pi over 3. Cosine of pi over 3 is 1/2. 1/2 times 2 is 1. Down here would be cosine of pi, which is -1. -1 times 2 is -2. And down here would be cosine of, let's be careful here, 5 pi over 3. Cosine of 5 pi over 3 is actually also 1/2. 1/2 times 2 is 1. So now we get our values. Next we have our column of signs. Since I got a positive value for this test value, then I'm going to write positive here. And I know since it's positive, it's going to be increasing for the last column. So this will be increasing from 0 to pi over 4. I plugged in pi over 2 in for this interval, and I got a negative number back, so I know it's going to be decreasing on that interval. And I plugged in 5 pi over 6 for the interval of 3 pi over 4 to pi, and I got a positive number back, so I know it's going to be increasing again. So it goes from increasing to decreasing to increasing. Step 4, we're going to write out a verbal explanation. It's going to be increasing on 0 to pi over 4 and 3 pi over 4 to 0. No, not to 0, it should be to pi. Okay, so it would be increasing from 0 to pi over 4 and 3 pi over 4 to pi because the derivative is positive for all x values over those intervals. And it's going to be decreasing from pi over 4 to 3 pi over 4 because the derivative is negative for all x values on this interval. So make sure you give a verbal explanation and the reason why. Now let's take a look at the graph and confirm our results. Okay, here we have our function sine of 2x. We're going to go ahead and just trace this graph and look at the tangent line. We can see as it starts from 0, it is indeed increasing. Okay, and once we get to this value right here, which was our first critical value, we're going to have to go back and take a look at what that was. So that was at pi over 4. We can see that it's going to start decreasing from there. So it increases from 0 to pi over 4 and then starts to decrease from pi over 4 all the way to our next critical value, 3 pi over 4. And then we can see that it starts increasing there until it gets to pi. So there's our graphical confirmation of the chart we just generated. Goes from increasing to decreasing to increasing. You can see the relationship it has too with the tangent line. That's it for this example of increasing and decreasing for a trig function. If you have any other questions about it, let me know.